Welcome to Module 1 of our machine learning journey, where we are about to dive into the fundamentals of machine learning. Feel free to take your time, revisit sections if necessary, and don't hesitate to ask questions in the comment section below. Learning is a gradual process, and we're here to support you. So let's explore together on how machine learning can be used to elevate your research. The Sydney Informatics Hub is a core research facility supporting computational and data-driven research. But at the heart of it all, we are a facility built on people with diverse expertise in data science, computing, and beyond. We offer access to research infrastructures such as high-performance computing, project and grant support through flexible consultations, and events such as happy hours, seminars, and training workshops, just like this one. Our areas of expertise span across 4 key domains: statistics, data science and software engineering, research computing, and bioinformatics. This may include shaping robust experiments and harnessing AI as predictive tools to large-scale modeling and custom omics pipelines. To engage with us, you can reach out directly through our Contact Us button on our website or scan the QR code and fill out our request form. You can also send us an email and we'll promptly be in touch. This is the first of 4 modules in our exciting new machine learning workshop series. Module 2 is also available, so please don't forget to check that out at your own pace. Please remember to register in Eventbrite for modules 3 and 4, where you'll be getting hands-on experience of building models and turning them into predictive tools for research. What is machine learning? It's a branch of AI that teaches computers to learn from data, make decisions, and predict without direct programming. This process involves several key steps. First, you start with the input, which is sometimes paired with an output that represents the desired outcome or label. Through training, the algorithm then learns patterns in the data and creates a model. So when this trained model is confronted with new input data, it uses these patterns to predict an outcome. Deep learning is a more complex form of machine learning, using deep neural networks to handle things like image and speech recognition. It's important to note that all deep learning is machine learning, but not all machine learning is necessarily deep learning. Machine learning covers a broader range of techniques, and the 3 main types of models are supervised, unsupervised, and reinforced, each suitable for different tasks and types of data. Supervised learning involves training an algorithm on labeled data, where both input and corresponding output is provided. The goal is to learn mappings between these pairs to make accurate predictions or classifications. Regression models forecast continuous values, like temperature and degrees Celsius, whilst classification models categorize data based on predefined groups, like whether it's going to be hot or cold. Unsupervised learning involves training an algorithm using unlabeled data. The goal is to find hidden patterns or relationships within the data without specific instructions. Tasks involve dimension reduction and clustering. So, for example, when looking at thousands of genes, simplifying the structure and grouping similar data points can help find key disease biomarkers or cell subtypes. Reinforced learning is like teaching a crow to bring shiny objects. When it does, you reward it. Eventually, the crow learns to select shiny things for more rewards. Essentially, an agent interacts with its environment and receives good or bad feedback for an action. The goal is for the agent to learn actions that lead to the most rewards. Some popular use cases of different types of machine learning in nowadays society, including things like recognizing images, like Face ID, turning speech into text, think Siri, predicting traffic for better GPS routes, suggesting products online, self-driving cars like Tesla's autopilot, and improving email with spam filters. These are just some examples that underscore the transformative impact of machine learning across various domains, showcasing its ability to improve daily life. In machine learning, the primary goal is to predict future outcomes accurately, not just replicate existing data. This skill is called generalizability, showing how well the model works on new data. But if a model follows the training data too closely, it leads to overfitting, and as a result may struggle with new data. So striking a balance between fitting data and generalizing is key. That's why techniques like the train-test split are important in machine learning. The training set teaches the models patterns and the tasks it needs to perform, the test set checks how well it does with new data. This makes sure the model is accurate and works well in real life, avoiding overfitting and giving trustworthy predictions. But before we even get to that, the data needs to be prepared to make sure that it's suitable for training and evaluation. First thing is to get accurate and reliable data. Next is cleaning and transformation of the data, which is often the most time-consuming step. This may involve handling missing data, addressing class imbalances, removing outliers, and other feature engineering steps. The clean data is then reshaped into the required format, integrated if necessary, and stored for the next steps. Your data budget decides how much goes into training and how much goes into testing during the split. And this choice matters a lot in machine learning because it affects the model's performance and how well it evaluates. Common cutoffs include 70-30, 80-20, or 60-40. Too much training data might make a model great with familiar stuff, but not new things. Too much testing data can give a good evaluation, but the model may not learn enough. So the key is balance, and some factors that may influence your choice include the size of your dataset, model complexity, and available resources. For example, the more data you have and the more complex model you want to train, you need more training data, which also requires more computing power. Cross-validation is a valuable technique for evaluating the performance of machine learning models during training. It's especially helpful when you have limited data, but really, it's beneficial for any dataset size. It involves splitting the data into subsets or folds, usually 5 to 10, providing a more comprehensive evaluation than a single train test split. And this rotation ensures that each data point is evaluated for K amount of times, making it more robust. For imbalanced data, you can balance each fold using resampling techniques. But be careful, too much oversampling can overfit, whilst undersampling loses information. So think well to pick the right method because it will help decide things like model choice and hyperparameters. Hyperparameters are settings that are not learned directly from the data, but control various aspects of the learning process. They significantly influence how well a model performs and are selected before starting cross-validation. Cross-validation helps to optimize hyperparameters and can keep fine-tuning it until you find the best combination. In the example provided, we use a learning algorithm with 3 different hyperparameter settings to fit models to the training data. After comparing the performance estimates, we choose the hyperparameter settings associated with the best performance. Assessing model performance and accuracy involves evaluating how well a machine learning model's predictions align with the actual outcomes or labels in the dataset. It's important to choose the appropriate metric based on the specific nature of your machine learning task. For example, if you're working on a regression problem, metrics like mean squared error and R-squared are more relevant. For classification tasks, this may be precision, recall, confusion matrices, and area under the curve. Whereas in unsupervised and reinforced learning, the concept of ground truth often doesn't exist, so traditional metrics may not apply. The bias-variance trade-off is closely tied to evaluating a model's performance. Bias is the error from simplifying a complex real-world issue with a basic model, whilst variance reflects a model's response to noise in the training data. In essence, the trade-off reminds us that a model cannot simultaneously have 0 bias and 0 variance. As you aim to reduce one type of error, the other type tends to increase. And the balance between these 2 types of errors determines a model's ability to generalize to new data. Simple models tend to have a high bias and low variance. They may not capture the underlying complexity of the data, but are more stable and consistent across different datasets. Complex models have low bias and high variance. They can capture intricate patterns, but are sensitive to variations and may not generalize well to new data. But the real test is the model's performance on real-world datasets and new samples. This process helps ensure that the model is not just memorizing training data, but genuinely learning to make meaningful and accurate predictions in practical situations. So ultimately, the goal is to transform these trained models into predictive tools for research in the real world. This may involve creating user-friendly interfaces with tools like RShiny for easy interaction, and to ensure smooth use and steady performance. Containerization with Docker can pack your app in what it needs, making sure it works the same everywhere. Then putting the app on a cloud platform boosts worldwide access, letting you grow and manage it well. The streamlined process empowers you to harness the complete capabilities of your machine learning models, delivering valuable services to users effortlessly and effectively. As we wrap up, your feedback is invaluable to us. Please take a moment to scan the QR code and share your thoughts. We sincerely appreciate your engagement and encourage you to explore additional information via the provided links. Don't forget to show your support by hitting the like and subscribe.